Okay, great. So, hello everyone. Thanks for joining us. We are here today to explore the XTRA-N G3 series, our latest advancement in solar charge controller technology. And this series marks a significant step forward in our commitment to innovation. So we are offering enhanced efficiency, connectivity, battery compatibility, and lots of other features. And as we cover the details, you'll discover how the XTRA-N G3 is designed to meet the growing demands in off-grid energy systems, ensuring optimal performance, compatibility with lithium batteries, and battery longevity. So our focus today will cover the technological advancements which set these series apart, including the refined MPPT algorithm, the integration of lithium battery compatibility, improved connectivity, and of course the extra protection. So, outline of the content. We will start with an introduction to set the stage, followed by an essential question, indeed the need for an innovative solar charge controller. Why need controller? It's been so long that controllers are there. So did we really need a new charge controller? We will cover this question, and next we'll introduce our solution, and we'll cover the evolution from the previous XTRA-N series to the current XTRA-N G3 series, followed by features and advancements to highlight the technical enhancements and new features. And following that, we'll take a look at the accessories designed to complement and extend the functionality, and we'll make sure to spare some time for your questions, of course. One might question the need for a new series. When MPPT controllers have been around already for many years, why one would need a new charge controller? So, in spite of advancements, we recognized areas for improvement, especially regarding the battery life. The longevity of batteries is important. If not taken care of, it can hit us right direct in our pocket, and charge controllers have a significant role to play here. Also, better protection solutions were still needed, particularly for systems with lithium batteries, because things like unexpected disconnection of battery management system could risk our components, or events like overcurrent, which is quite normal in an off-grid application. If you're in this industry, you know better than me that these events like overcurrent were anyhow present in many daily applications. So we needed to find a better solution, a more protective solution. Also, seamless and reliable connectivity was a challenge for system monitoring. And also there was a room for optimizing the system, factors like self-consumption rate and even the smallest energy savings were of interest in many applications. So just imagine a remote off-grid system with a limited battery capacity, multiple sensors are running on that, and you really are counting on every milliamps of your system. Therefore, you needed to have a better optimized charge controller with a lower self-consumption to meet that requirement. So for all these problems that were still in the industry for the charge controllers, we thought of a new product. Here is it. The G3 series is our response for those demands. It comes with an improved MPPT algorithm, an adaptive charging method to ensure the highest conversion performance and longer battery life. And the G3 battery care is a special one because it has a constant voltage output. So we will dive deeper into this concept in a while in the coming slides, that what a constant voltage output means in practice. And also G3 has a built-in integrated Bluetooth function for robust and flexible communications, which eases the real-time monitoring, adjustment, and I would say it's essential for many solar applications nowadays, especially with the mobile ones. And we're also setting the new benchmarks for, as described, the energy efficiency and the noise reduction. It's an ultra-quiet device, and we will cover each feature separately in the coming slides. So let's dive deeper into the details of features just presented. We start with the MPPT algorithm and the adaptive charging. So with the new enhanced algorithm, the tracking speed and response speed has improved. Therefore, we have minimized the loss rate in terms of energy and the lost time in terms of finding the optimal point of the system. Also, the DC to DC conversion efficiency, both in high and low power segments, has been fine-tuned. This means that we are more adaptive to the variable irradiance conditions throughout the day, whether it's quite sunny or it's cloudy or whatever. The system ensures to find the optimum power point, maximum power point, in a much more quicker manner. And then also the hardware changes makes it more efficient and with a high proficiency. And adaptive charging in G3, the diagram that you see on the left side represents the adaptive charging profile, kind of. So this charging profile ensures that the battery health is managed via intelligent charge states. And this is done by utilizing stages like bulk, boost, equalize, and float. And this adaptive approach means batteries are charged optimally, enhancing their lifespan, their performance, which is also financially quite important when budgeting for solar applications. The next feature was, as you remember, the compatibility with the lithium batteries, as you recall. And in charge controllers, this means the ability to correctly and safely charge lithium-based cells. So lithium batteries have different charging profiles, you know that. And protection requirements are there, built in with the lithium batteries, so they are different from traditional lead-acid batteries. And a compatible charge controller must be able to provide the correct voltage and current and manage the precise stages that the battery requires, and more importantly, responds to the built-in BMS function. So we always say that BMS is good. Yes, BMS is good for the battery, but when the BMS disconnects the battery, there is a risk of failure for the other components in the off-grid system. We learn in the next slide about why this is harmful and how G3 is tackling this. So the constant voltage output and limited current was our response to these challenges. So if we want to look closer into these functions, let's just start with constant voltage. So imagine it's a sunny day and your solar panels are generating more power than what your loads currently need. So everything runs smoothly until suddenly the BMS or your lithium battery detects some issues, whatever. It could be overcharging or anything in your system. And at that moment, the BMS just disconnects to protect the battery. So in a typical setup, the disconnection could cause a surge in voltage. So the left picture and the middle part, the pink graph, you see the surge, and this surge leading to potential damage to your inverter and other connected loads. However, with the G3 constant voltage output function, the controller immediately steps in, provides a stable voltage output, prevents the spike, and it just prevents anything that could harm your equipment. So it's indeed adapting the output voltage to some safe level for your specific system, whether it is 12 volt or 48 volt, etc. So instead of experiencing harmful voltage jump, your system continues to run without a problem and keeping even your loads powered and protected. So no matter the battery is disconnected, your loads are powered. So if you compare the two pictures, here you will see how the overshoot is managed in G3 in the right picture. So this means that even if the BMS disconnects the battery due to overcharging, or other safety concerns, the G3 can keep the power flowing to your loads without interruption. Yes, a charge controller that works without battery. It automatically adjusts the output voltage to manage the voltage required by the system, so it knows it's a 12 volt or 24 volts or 48 volt system, so it manages and changes the voltage to meet the requirements of the network of the loads, which inverter is one of them. So yes, what you see here in the left side is a typical charge controller, while in the right side, the G3 series, which is actually powering the load via the PV directly in cases of disconnection without a need for battery. And of course, there is no voltage overshoots that you expect from a typical system that might damage the inverter or other connected loads. Another protective feature implemented is the output overcurrent protection. So these figures here, the three figures, illustrate the response to overcurrent event. In a typical solar system, an overcurrent scenario might occur because of many reasons. For example, during a fault condition, or when you connect a large load, or you activate a large load from your inverter. So current might spark. That's called the inrush current, and it's quite common in off-grid applications. So the left image shows a spike instance. So the pink one, you see the current goes up, where the current suddenly rises. In this particular example, it's 90 amps. And in a typical system, this causes significant damages. However, the G3 series quickly detects this surge and responds within milliseconds. And the second image shows the immediate drop in current. You see that the current has dropped with the G3, and the controller disconnects the load for a brief 15 milliseconds, as seen in the third image. A pause that allows the conditions causing the overcurrent to stabilize, to clear, and then when that condition is gone, the controller re-establishes the connection, aiming to maintaining operation without a prolonged shutdown. So the right image demonstrates the system returning to normal conditions in a very quick time span, 15 milliseconds. And this quick reaction not only prevents equipment damage, but also ensures uninterrupted power delivery. We might have an application that requires continuous power flow, like a medical system or whatever. So this ensures that while the system is protected, it doesn't restart because of the power interruption. So with a focus on how it precisely handles this, you see a close-up view of the oscilloscope here. At the critical moment of overcurrent, the controller's internal mechanism, which includes MOSFETs of phase A and phase B, they engage and quickly bring the current down by disconnection, and effectively switching off to protect the system. And this lasts only for 15 milliseconds, after which the controller resets the output, a quick action that minimizes downtime. And in this picture, you actually see how the controller is equipped with overcurrent protection for safeguarding against all those phenomena that we already discovered, like the potential damages from large loads or currents or short circuits at the battery terminal, which I would say is a great feature for a charge controller. So the next feature is the built-in Bluetooth. Yes, the Bluetooth interface offers wireless communication, providing the ease of remote monitoring and parameter adjustment via a smartphone simply in your hand, and it simplifies the user experience, shall we say. In parallel, the RS-485 connection delivers a reliable, hardwired communication path, and you have Bluetooth built in. You have the RS-485, the Modbus communication wired. So this combination is good for a robust continuous data exchange. And this is indeed the I would call the versatility in monitoring and system interaction. So you have a local monitoring system connected via Modbus port to your controller. So you have your local monitoring there, and at the same time you're using your phone to configure, to monitor and configure, parameters, etc., which you might need to do. And this eases the user experience of setting the parameter and monitoring that. So you can use both connections at the same time, no disconnections in between, and there's also a PC software available and a mobile application available so that you can monitor and configure your system. So now we have the enabled control, and what it actually means is the G3 model provides an option to disable the communication port through the LCD screen. And this is a feature which aims to reduce the device's own energy consumption, making the system more energy efficient, because then it reduces the amount of power used for COM-port communication, and this settings is handy with the systems with, we have had multiple applications with energy saving is critical, and it extends the system's standby time. So you have the flexibility to enable or disable communication function as needed to save more energy from your battery and have a low self-consumption charge controller there. So we are talking about, in a normal condition, 30 milliamps at 12 volts of a self-consumption, and diving deeper, we found that when the communication port is turned off, the controller becomes even more energy efficient and self-consumption drops by below 8 milliamps at 12 volts. So you are reducing from 30 milliamps to 8 milliamps for 12 volts, for example. And this function is specifically useful during periods of low solar activity where every milliamp is important. So by disabling this function, we are talking about an extended standby time of a magnitude of 70%, which is quite significant. We also have the ultra quiet function. So it's not only about the power, but at the same time we have an ultra quiet charge controller with a lowered noise, so that you can easily use that in a built-in environment, like if you're using it in a home, small tiny home, or if you're using that in a van and you're resting, then charge controller is not interrupting there by the noise. Now we progress with the integral aspects of remote monitoring and the electromagnetic compatibility. So as an upgrade, now we are gone a step further with the local monitoring devices with the MT52 gadget. So this enhances the functionality with additional temperature settings for lithium batteries. So again, something about lithium batteries, which is essential for systems exposed to temperature variations. So this is compatible with MT52. And also about the EMC, or electromagnetic compatibility. G3 ensures that, there is a standards in place, and they ensure that the device complies with the FCC's Class A and Class B standards for industrial and residential environments. We haven't yet got a certificate. We are working on that. We are in the final stages, and there are some challenges with those certificates there, because they're kind of wiring and all those kind of application side stuff might affect the amount of the EMC that the device is propagating. So it might be challenging to define it for Class A and Class B so far, but we are hoping that we will be getting the certificates of the EMC for both classes in a timely manner. So the compliance is still under process. So again, here about the display units, the previous series, the XTRA-N series, which were also really successful series, had 3 options available for the local display: DB1, DS1, and DS2. So based on the voice of the customer and the feedbacks that we've got from the customers, now we are convinced that we will suffice to only DS2 display unit, which, as you can see, there is this LCD together with a couple of buttons for local parameter settings, for monitoring, and etc. And this is the only display available for G3 sections, of course based on your feedback from our previous series. And yeah, finally we have the load working modes, which are enhanced for G3 series. The texts are small here, but for those of you who have used Epever charge controllers, you're already familiar with the common load working modes here. What is a load working mode? So you have load terminals, you connect your loads there, and apparently you don't want them to be on all the time. You want to turn them on or off per conditions. So we had the manual mode, which allows us to turn on the load on or off, manually. Then we had light on or off mode, which enables the load to be activated based on the radiance conditions and the available voltage from the PV panels. Then we had another light on plus timer mode, which provided the ability to have the load turn on and off with the light and stay for a certain period. So it's like, hey, during this, when the sun set, the sun is there, the radiance is there, the voltage is high enough, keep the load on for the next 6 hours. And we also had a real-time control mode, which allows for the load to be managed based on real-time conditions and requirements. But now with the G3, we understood that, okay, we need a little bit more flexibility on how we play with the loads, when we turn them on, off, and how long do we do that. So we have the new light on off plus timer mode, which turns the load on at night and off during the day, and the light on off plus timer mode 2, which allows the load to be on during the day and off at night. And we also have the always on mode for the applications that you really need to keep a load on throughout the day. So again, this is all about user experience and the ease of use and the control over your loads. So these modes increase the flexibility and customization of the load control, meeting more application scenarios. For instance, some clients, as I mentioned, may need the load to be operational during the day and off at night, something like that, and which can be configured via the G3 additional modes. So in summary, if we want to compare the two series here, as you can see, and in the first row you see the XTRA-N, the previous series, and the second row is the XTRA-N G3 VLE series. So you see that we have only one display unit option, we have a built-in Bluetooth function embedded, we have a constant voltage output to prevent the voltage overshoots, we have output over current protection in cases of overcurrent in the system, which are quite common. Then we have this communication enable or disable functionality to save the power. The ultra quiet and low power design is something that is also improved in G3 series. And then we have charging voltage and max current limiting settings for the new series in a different range. We have extended load working modes. The remote meter has changed, and the EMC is under application. So this is like a snapshot that summarizes the whole R&D, marketing, sales endeavors in the past couple of years for Epever company to show our commitment for innovation and producing the products that really are suited for customer specific problems. And this is I think just showcasing the amount of the significant changes has made and improvements that has made in these series, which were, as I mentioned again, which were already a successful series in the market, in the solar off-grid market. This slide presents the kind of accessories that you can connect. As I mentioned, MT52. You have a cable to convert from RS485 to USB and vice versa. You have the visibility to connect the Wi-Fi adapter 2.4G. The Bluetooth adapter might not be needed because you have this built into your system. And then the Epever, what you see in the top, the first row is the TCP306, and it's a device that connects Epever solar products to a network for remote monitoring and configuration. So it uses a TCP/IP over Ethernet cable for network communications and is typically deployed in a LAN connection. So this is suitable for managing solar power systems remotely via TCP/IP. You can connect, monitor, adjust the settings, etc., which is quite handy if you want to do something, from a remote location. And then the Epever RTU 4G HE01, what you see in the row 6, the middle gadget in the screen. This enables the Epever solar products to connect to the internet via a 4G cellular network and then broadcast the data towards our cloud monitoring software. So it's designed for use in remote locations where wired internet isn't available. And with GSM or GPRS connectivity, users can manage their solar systems throughout a cloud platform or mobile app, making it essential for real-time monitoring and control for solar installations and applications. So if you have a remote system, you would love to have kind of control over that or get the data out of it and use that in the cloud software, this is the gadget go. This is quite common in telecommunication applications, where you have just a standalone setup there, and every now and then you need to check your system and have control on, for example, workload, load working modes, and etc. So these two devices, the number 5 and 6, basically enhance the capability of the solar systems, making them accessible and manageable remotely. So then, of course, we have the remote battery temperature sensor in the line 7, which also helps to effectively read the temperature from the battery using a typical thermistor, using an NTC from the battery. And then there are functions associated in the charge controller in that regard, that if the battery temperature is in a critical range, then it takes actions based on that. For example, stops charging for lithium batteries or this kind of stuff. So yeah, with that, I would like to thank you for your attention, and we are here to go over some sort of questions that you might have regarding the G3 series.